All right, guys, so anybody have any trouble with what you had to do last night with circles? Anything? Because I think there are a couple of curveballs in there, maybe. Anybody have any problem whatsoever? Are we good?
I'm kind of confused about like when it gives you letters. Like I don't know, like for like 17 on 404. I'm just kind of confused on like
17 on 404.
Yeah. It's one where it like was like squared.
Oh, they're just trying to screw with you and see if you know your rules. Okay, so this doesn't really feel like a problem I would ask for what it's worth. But let's take a look. So they gave you the points A plus B?
B.
That the one you're asking about?
It's the yes, A plus B.
So A plus B, A minus B. So those are coordinates. I just don't know what the A and B are, but I'm gonna not worry about it. And then the other point is B minus A, B plus A. I haven't done this problem in so many years. And it says, find the distance between each pair and the midpoint of the line segment joining those points. So they're really trying to just work you over a little bit with the algebra. So let's just stick to what we know and be really careful. The distance formula says to go x minus x, right? So I'm gonna go x2, and it doesn't matter which order, minus the whole other point. So minus that squared. And then it says to go y minus the whole other point squared.
So it doesn't matter the order?
Doesn't matter the order. And if I switch up the order, I'm going to get, one's going to be like, you'll see right here. So when I distribute that, if I do it this way, I end up getting A plus B minus B, positive A, quantity squared. And here I get A minus B minus B minus A, quantity squared. And when I clean this up, I get 2A squared negative 2B squared. The only difference is if I were to go this minus that, instead of getting 2A, guess what I get?
Oh, 2B and 2A.
I get negative 2A. Look, if I go the other way, B minus A minus A plus B, I get B minus A minus A minus B, I get negative 2A. And the reason why I know that is, when I go 10 minus 7, or 7 minus 10, what changes? 10 minus 7 is 3, so 7 minus 10 must be negative 3. So if this minus this is 2A, then that minus that would be negative 2A. But it doesn't really matter now that I'm squaring it? No. So I end up with 4A squared plus 4B squared square rooted. And I'm guessing that they didn't write the answer like that. My guess is that they probably said, well, I could factor out the 4 from the A squared and B squared, and then I could make that 2 on the outside. But I cannot do anything with this. I know the temptation is to say, why isn't that A plus B? Well, that's just not the algebra we know. To be able to factor something, I have to have the same thing twice in there, right? Like I need to have like blah times blah. Like I can take the 4 out because that's 2 times 2. But what times what gives me A squared plus B squared? Does it?
That's A minus.
Yeah, see, nothing gives me this. That gives me A squared minus B squared. But even if it was A squared minus B squared, does it give you the same factor?
No.
Then you couldn't do anything with it. So this is just prime. And by the way, if you ever forget stuff, check it with, like, if you're thinking, wait a minute, is A squared plus B squared A plus B? And you're wondering, check it for some numbers you know, right? I mean, plug in something like, all right, I'm going to plug in when A is 5 and B is 2. So that should be root 49 equals 7 if it's true, right? But look what I end up with. 25 and 4 is root 29. Is that 7? No. And if that's not true, this rule doesn't work. So I've done that my whole mathematics life. If I'm ever questioning something and I'm not sure, it's not good proof, but it is a good little check. Just run something through there and see if it works. And avoid zeros. I mean, don't plug zeros in for A and B. Then it's like, oh, it's true. I mean, some numbers aren't good checks. Or ones. I mean, 1 actually is not true here, but plug in numbers that, just some random numbers that, if it's true for this, if it's true, it would be true for everything. So that tells me I'm done. But that's just ugly algebra. They're just messing with your brain. So that's the distance, and then what would the midpoint be? And if, by the way, if you're wondering, what the heck does that even represent? Again, they're just checking your ability to do algebra, but that means for any A and B that you know, like for instance, if I said, if A is, hey, I'll do something that makes sense. If A is 3 and B is 4, randomly, I'm just picking 3 and 4, then that would give me 7, -1, and then that would give me 1, 7, right? Well, if I do the distance formula with these 2 points, I should get 2, the distance should be 2 times the square root of 9 and 16, which is square root of 25, which is 5, so the distance should be 10, if I do this. And I bet I can draw a picture of this, looks great. 7, -1, and 1, 7. 1, 7, right there. But look at this. That's a total of what? 7, 8. This is a total of 1, 2, 3, 4, 5, 6. Oh, right here, I'm sorry. 1, 2, 3, 4, 5, 6. 6, 8, 10 triangle. So just checking a random point, a random A and B, you kind of confirm that your math is right. Anyway, for whatever that's worth, if you're, I know deeply most of you are going, you're going to ask that on a test. No, it's not important to me to beat you down with algebra at every turn, especially on a conic sections chapter. It's not, I'm not checking just raw algebra here. It's more about, do you know what conic sections are doing? All right, so what about anything else on that? Oh, it also said midpoint, but on midpoint, what would you do? Add the x's divided by 2, add the y's divided by 2, call it a day. That's your midpoint. All right, what else? Anybody else on the homework? Or you good? All right, let's jump to parabolas. Here's what you already know. You already know that this is called what? Huh? Parabolic form, right? There's also a way you can write it as a function, which would be f of x equals ax squared plus bx plus c. But the only thing these two things have in common is that a and then the x's and y's, I guess, both represent points. But this is parabolic form of a parabola, right? And the hk are that's the vertex. And if I take a, we don't really talk about this relationship much. That's what's in the book. That's the relationship between A and C mathematically. What we normally do is say this. If I flip the A, I get what? I get the lattice rectum. So if I flip the A, I got the length of the lattice rectum. And if I divide the length of the lattice rectum by 4, I get C. So that's what the lattice rectum is 4C means. That's our way to link C and A. And that's true whether the parabola is going up or down, or what we're going to talk about today, also left or right. Are we good? Okay. So, and we know that the C is always the distance from the
Center.
What we call the vertex to the
Focus.
focus, which we have not talked much about, but from the center to the focus. Now, there's also something on a parabola called a directrix. And I don't know if you've talked about parabolas in this way or not, but the directrix and the focus are really what's important on a parabola when you talk about the actual definition. So here's the actual definition. I'm going to get away from this for one, well, I think I'll just show you down here. We're going to go down here. So hypothetically, let's say the only two things I knew were a focus and a directrix. Ignore everything else on this page, okay? Now, the definition, or one definition of a parabola is this. So the definition of a parabola, I don't know why I don't have this in the notes, but here's one definition. All the points in the plane, all points in a plane, which are the same distance from both a fixed point called the focus and a fixed line called the directrix. So again, as you're copying this down if you want, and yes, I have sometimes asked you about the definition. I don't ask you to write it, but sometimes I ask you to match. Like you know the definition of a circle. How would you define a circle? All the points in the plane that are what? Equidistant from a fixed point called the center. And that distance is the radius, right? Well, this is the definition of a parabola. So basically, I just have a fixed point and a fixed line. And now I just got to go in here and eyeball. Actually, don't have to eyeball, but I could eyeball the points that are actually the same distance away. Now, is this point the same distance away from the focus as it is the directrix? No, that's why it's not on there. Is this point the same distance away from the focus as it is the directrix? Nope, that's why it's not on there. But all of these other points, starting with the vertex, same distance, same distance. The endpoints of the lattice rectum, same distance, same distance. Same distance, same distance. But even these in here, that, same distance. That, same. That. All those distances, there and there, there and there, there and there, all those distances are the same. That's the definition of a parabola. And to define that algebraically, you can see it in your book. I'm not going to go through it because it's a lot. But if you look in the book on this chapter, they do an example and they use the distance formula. They literally do a distance formula from a point to a vertex, from a point to a focus, and then they do another distance formula from a point to a directrix, and they set these two square roots equal to each other, and then they start cleaning them up, and they end up with a y minus k equals a x minus whatever squared equation. That's where these equations come from, technically this equation. We're not going to do that. We're just going to take graphs, write equations using the tricks we have, because it's easier, or we're going to take equations and graph them using the tricks and the lattice rectum and the cheat trick and all that we have. Just because it's easier than doing this, okay? So anyway, the directrix, remember, is a line, and this example that I gave you here is an example of a y minus k equals a x minus h, because the parabola is going up. But again, if I switch directions, subtle things change. But make sure you understand the directrix, the distance to that directrix is also c because of the definition we just wrote.
Wait, if your parabola is going sideways, is your directrix like this?
That's right. So if I shift gears and all of a sudden I got a parabola that looks like this, my focus is still going to be kind of in the middle there. And I can draw you this lame little picture that helps you remember this. But my focus is always going to kind of be in the cradle of the parabola, and my directrix is on the other side. Okay? So if it's going down, my focus is always kind of in the concavity of the parabola. Directrix would be on the other side. And because the directrix is a line, make sure you write it as a line. What do lines like this, what would that line be? Y equals 1, because it goes through y equals 1. Doesn't matter what x is, right? What would this be? X equals something, right? Y'all with me? Because it's a vertical line, and that's what vertical lines look like. And we're not going to do any parabolas that go diagonal this year. We will actually look at how that actually happens. If you have parabolas that are tilted on an axis, but that's pre-cal topic at best. It's a pre-cal topic. Are y'all with me on this so far? So far, when you look at this, most of what's on this sheet you already know. Now, one thing I did not talk about yesterday that I need to talk about today is something called eccentricity, or some people pronounce it as eccentricity. I've just heard it so many different ways, I don't even know what's right. Okay? So, at least over the past 28 years. So, there are eccentricities that measure your conic sections. I didn't mention this yesterday, but you can write this in on the page before where the circles notes are. The eccentricity of a circle, if it's not already written there, eccentricity of a circle is 0, always. Because eccentricity, in its way, measures shape. Okay? And circles, the shape is always the same. So whenever your E value is 0, and believe me, there's more that goes into that E value than I'm really giving you, but E is always 0. And for parabolas, the eccentricity is always 1. And you may say, well, why is that true? Because if it measures shape, some parabolas are skinnier than others. But I would argue that's kind of true. Keep this in mind. Even if I have a really steep parabola, are you with me? What happens if I start zooming in right here? If I zoom in right here, and then take that and blow it up, what do I see? A wider one. And if I zoom in again and blow that up, what do I see?
A wider one.
Even wider one. And vice versa. If I have a wide one, like a parabola looks like this, and I zoom out so that I see the whole parabola, what does it look like from the way back? Very steep. So I could argue that the shape of every parabola is similar. I could take any parabola, go to a copy machine, if I had this ability, and continue to zoom in, and it will almost look horizontal like this, if it's assuming it's going down or up. It'll look very flat. And if I was able to zoom out on them, now I know if you keep zooming out, there's only so much paper, you're just gonna see a little box, but assuming you could zoom out and still see it change, you would see really wide ones as you zoom out, start to become really steep. So that's why, one of the reasons why these things have fixed eccentricities. However, if you think about an oval, there's a lot of different ways to draw an oval, aren't there? I mean, you could have ovals like this, that are just a little oval, some that look like this, really, some that look really skinny. And there's nothing I can do zooming in or out to make this look like this, is there? Are you with me? So these actually have changed, and same thing with hyperbolas. You can have hyperbolas that look like this, and hyperbolas that look like this, and there's nothing I can do zooming in or out. These have different shapes, right? And so the eccentricities of those will change, and I'll talk to you about how those change tomorrow on the next day. Are you with me? So just remember, eccentricity of a circle, this is like a ciphering question. Oh God, what is the eccentricity of the following parabola? And we have yet to get this right. Like, I beat it in like the years we've done it, maybe I haven't talked about it or something, I don't know. But like the eccentricity of the following parabola, my kids are like scribbling out stuff. And I'm like, ugh. It's just always one. So if you're not gonna have any ciphering this year because the only test we're gonna have is the state tournament. At least they have plans to try to do that, although we'll probably be doing it in the building somewhere. But if that ever shows up, eccentricity of a circle, always 0, which is easy to remember because zeros look like circles. Eccentricity of a parabola, it's always 1. All right? So we know so far most of this stuff up here. I'm going to talk about what we don't. So on any of these given parabolas, we should be able to complete the square. Have we talked about completing the square on these? Yes. So like on this particular one, the one thing I might do differently now that I didn't do here is sometimes if I look at it and I go, wait, the x's are squared and the y's aren't, where do we typically like the squared parts?
On one side.
On the right side, and the non-squared stuff on the left? So another option here would be to say, you know what, if I want, instead of doing this, I could take the squared stuff, the x's, move it over, which would give me negative 2x squared, negative 16x, and leave the negative 16y and the 80 right here. So this is another option if you think you'd like this better. If not, do this. And what I did is I completed the square and got everything ready, and at the very second, like maybe right here, I switched sides. and I put them there. But if you want to switch it at the beginning, do this. So look at the difference. What do you need to do to complete the square here on the squared part? Now, I could divide it out, but if I divide it out, I'm putting a -2 under the y, and I don't have anything under the y, so what would be better? And it's the a value, right? Why wouldn't I want to take that a value and pull it out? Because it's the number with the x squared. So I'm going to just factor it out, but what does that make the -16? +8. Nothing changes over here. Then, how do I complete the square? So when you half it and square it, I get, and I add a 16 to the right, but what really happened to the right side? It was 16 times the -2, right? So that put a -32 on the left. So that gives me -16y plus 48, -2x plus 4 squared. Does that look like a parabola yet? It's getting closer though. What's wrong with it? There can't be anything with that y, can there? Because the y has to be just a 1y. So what would I do with that -16? So here's where people get in trouble. People go, oh, divide everything through by -16. Well, the rule is really divide each side by -16. Or you could multiply by -1/16, and that to me looks a little better. I'll show you that in a second. But if you do this, because there's a plus here, I got to divide it into both parts. But because there's a times there, you get to pick. So since it's plus, that into that gives me the y that I wanted. That over that is a -3. Here, I'm just going to put it with the a and get 1/8 and just drop the x plus 4. Now, do you like this or the one on the left? The one on the left just kept it there, factored out a 2, completed the square, added a 32, got to here, and then said, okay, it's about time, I need to switch sides, and then I divided by or multiplied by a 1/16. But I normally don't do this when I'm showing the math. I normally say multiply both sides by a -1/16, and then when you do the math, you can see that times that's 1/8, and it just never ends up traveling any further than that. Are y'all with me? So, if I had this problem, hopefully you can graph it because you did that on your last test, most of you very successfully. The vertex is at -4, 3, your lattice rectum is 8, the graph is going in which direction? Up. You know your C value is 1/4 of 8, which is 2. So you know you can go to that vertex, just like they did right here. You can go to that vertex and go up 2 over a total of 8. You've got the 3 points you need and you can sketch that. But if they asked you to go sketch the directrix, or what the directrix is, or if they asked you what the focus is, you already have the focus. So you could say, oh, the focus is at -4, 5, right? But if they ask you what the directrix is, instead of going up 2, what do? You go back 2, but you don't give them that point, you give them what? The horizontal line in this case, which would be y = 1. And you also remember the axis of symmetry, what would that be? X equals -4, which you could have found from that, or you could have looked at the graph and you remember the trick to finding the axis of symmetry? Take the squared part, set it equal to 0, and you get x equals -4. Are y'all with me? Now, I'm going to run through some classwork problems here. You have this on your sheet. We'll get as much as we can done. And I just want you to see that sometimes things change a little bit. And I want to show you these changes in real time with number 1 and 2. So what's different about 1 and 2 here?
It's x first.
It's x first. So if y first tells you it's up or down, x first would tell you left or right. What do you think a negative a value like this is going to do?
Left.
Send it left, okay? So you know this graph is going left. You can think about that. All right, I know it's heading that way. But the vertex is kind of the same thing, except don't pick -1, 3. The vertex is what? Because you pick the number with the x, right? So 3, -1. Now, the length of the lattice rectum, Same thing. What is it here? Positive 8. The A value? Well, you see it right there, negative 1/8, right? C value? Now, I probably should have said this earlier. If you're wondering why I put absolute value of C, by strict definition, if the graph is going left, C is a negative. If the graph is going right, C is a positive. If the graph is going up, C is a positive. If the graph is going down, C is a negative. But I don't think in terms of that formula that A equals 1 over 4C. And that would mean if A equals 1 over 4C and A can be negative, that would mean the C is negative. I don't think that way. So I will always ask you, what's the absolute value of C? It's not a trick question. It just means I don't care about the positivity or negativity. I already know it's going left from that. So all I'm concerned about is that little distance C. Does that make sense? Okay, directrix. Well, you might want to sketch this thing before we start answering too many questions. So on this, what do you know about it right here? So 3, negative 1 is my vertex. You know it's going left, so left how much?
2.
If I go 2 to the left, what is that? 1, negative 1, and that's the focus. I can fill that in. And you already know that the graph is going to the left. So what's the lattice? How do I fill the lattice rectum in here?
You have to go 8 instead of 4 each way.
But up and down now, right? So I'm going to go 1, 2, 3, 4 up, 4 down, and that's enough for me to sketch my parabola, in my opinion. But I still got to answer all these questions. So I've got a decent sketch, but how do I get this directrix? If I went 2 to the left to get my focus, 2 to the right, but every year I have somebody who writes 5, negative 1. But it's not a point, is it? It's the line going through that. And the line going through that is what? X equals 5. Make sure you write it as a line. And then what's the axis of symmetry? Y equals negative 1. So if I was graphing the axis of symmetry, which I don't think I find and label, yeah I did. So if I was sketching it, I would sketch that. Would be the axis of symmetry, and you can see that's y equals negative 1. But remember, you can always take the part that's being squared, set it equal to 0, and solve, and that's true whether it's x's or y's there. Still, same thing works. And then there's our sketch. And if I was labeling everything, I would label that's the directrix, that's my axis of sim, whatever. We good? And I guess I could label the lattice rectum too. That's my lattice rectum. All right, what about this one? This is going to be a little trickier in a couple of spots, but let's just stick to what we know. So it might have to use a little logic here. Okay, and you'll see what I mean in a second. What's the vertex?
Negative 2, negative 1.
Negative 2, negative 1. What's the length of my lattice rectum? 1/4. Ouch. What's my A? 4. What's the absolute value of the C? It's 1/4 of the 4th, right? So it's not pleasant like 1/4 of 8. It's 1/4 of a 4th, which is 1/16. Somehow I feel that's not going to be very helpful for me to actually find the directrix and the vertex, but it asked me to. So let's slow down for a second. Let's just do what we can do. Sketching this, what would I do? Negative 2, negative 1. There's my vertex. And what would you do to sketch it? Now the cheap trick for a positive 4 normally means up 4 over 1, right? But I'm going which way? I'm going to the right. So I want to go right 4, up and down 1. So it's not really like slope anymore, but it's still that same idea. So I can go right 1, 2, 3, 4, up 1, down 1. And I got a sketch, but I really did not even mark the focus or the whatever. That should not be coming back up here. Whatever. But they asked me for axis of symmetry. Now the axis of symmetry I can find. What is that? Y equals negative 1. And if I had to put that in there, I could. Right? And I've graphed it, but I still haven't found the directrix. So tell me where the directrix would have been. How far to the left?
1/4. 1/16.
C, 1/16. So let's think for a second. If I'm currently at the vertex What happens when I go left 1/16? I subtract the 1/16 from the -2 because I'm already at -2 and I'm going a -1/16 more. Are y'all seeing that? So if I take that -2, subtract the 1/16, I get -2 and 1/16 or -33/16. And that is what? But that's x equals equation. Are y'all seeing that? Now it's a whole lot easier though if it's a whole number, but if it's not, when you think about it, I'm really doing the same math. Now, how do I find the focus? The focus is on this side. I'm at -2, but I'm going to the right of 1/16. That's adding it, right? So I could say, well, -2, but I'm adding a 1/16. Well, -32/16 plus 1/16 is what? -31/16. Now, is the focus -31/16? It's what? -31/16, comma, down 1. So when you have a weird C value, a really small one like that, and the graph is going left and right, add it or subtract it to the x. If the graph was going up or down, add it or subtract it to the what? To the y, because it's going above and below the point. But the other value doesn't change. You'll see that -1 and that -1 are the same because I didn't change. They were still at that same y value of -1. It was only x values that changed. This is totally a test question where you're just pounding out information, just giving me stuff. What's the eccentricity of this very wide one? 1. Now, what's the eccentricity of this very skinny one? Still 1. Okay? All right, what about this? It says you're given the directrix. It's x equal -2. And the focus. So we're given a directrix, it's x equals -2. I would encourage you to graph it. What does x equal -2 do? Goes through the, right there? Is that x equals -2?
No.
No, that's y equals -2. X equals -2 has to go through x at -2. So that's my directrix. And it tells me the focus is 4, -3. It says find the equation of the parabola. What do you know immediately from this information? The vertex is in between. Great. So that's a total distance of 6. So the vertex must be there. So I know my vertex is 1, -3. What else do you know by looking at this graph?
Wait, how'd you find the vertex?
Well, because we know that the vertex is always 2 away from the, or whatever away from the focus, same distance away from both. So it would have to be in the middle.
Okay.
What else do I know?
Your lattice rectum, so your 18.
My lattice rectum is going to be what? How do I know that? Because this distance is C and it's 3. And 3 is 1/4 of the lattice rectum, right? That's how you found C. So if I multiply that by 4, I get the length of the lattice rectum is 12. And what does that help me find? The A value is what? 1/12. Except, again, I still have to make sure the A value has the right sign on it. Does it have the right sign on it?
Yes.
So you're telling me it opens to the right. Now if it opens to the right or left, which equation am I using?
X.
Instead of doing the y minus k1, I'm doing the x minus h1. And the y minus k is the part that's being squared. Are y'all seeing what I've been doing to get here? This would be considered a hard problem on your test if it was parabolas. So if you're like, oh, sweet, great. So all I have to do at this point is plug the vertex in. So where does the 1 go? With the x. I know habitually we've been shoving it in there. Remember, things are switched up a little bit. So the 1 goes there, so x minus 1. Y minus the -3 gives me the y plus 3. and we've already figured out the a value is a 12th because we know that this thing is heading to the what? To the right. So it must be positive. And if I'm sketching the parabola, at this point I'm going to go, well, if that's 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, my parabola would look something like that. Not too bad? How about this one? Equation of the parabola that has a vertex of 2, 3, focus of 2. I'll tell you, what time do we have? What do we have left? All right, let's work backwards. Y'all start sniffing? Oh. I think we're done with that. Who would want a powers quiz right now?
Not me.
I know.
4, 5.
No.
Who would die? Like, who'd be like, I freaking hate him.
I don't hate him. Boy.
Yeah. No worries. We're done.
Optional.
I don't know what we'll do on Pi Day this year, whether I doubt they're going to let us have food.
We'll just sneak it in.
Buzz kills, health conscious people.
Sneak through the window.
Tell you what.
We'll pass it through the window.
Yeah. You know, one year they banned Pi Day.
Why?
They just said no food in the class, and our principal's like, all right, we're just going to do it, just keep it on the down low. And the superintendent called him. This is a long time ago. He was like, I heard that you're allowing Pi Day. No, ma'am. He got on the intercom. Check that. No Pi Day. Well, one of my kids who worked at Sam's Super Sandwiches at the time had left early, so he got the memo in the morning that Pi Day's on, and then he left after a 4th period or 5th period because he had work release or something like that, and then they changed it the last minute. Well, he never got the memo, so he shows up with like 180 Sam's sandwiches or something like that.
Oh.
And he brings them into me, and I'm like in this massive container, and he goes, "Man, came through, Mr. Hurd." I was like, "Uh-oh." So I made sure it was okay. We kind of hid him away, but yeah, they don't do any of that now. But it was the health and wellness when Michelle Obama was doing that. No bad food, blah blah blah.
Oh,
So they had to shut it down, and then they finally just said, "Forget all that." Anyway, all right. So what about these guys? Let's think about these. I've got a parabola here. We kind of did something like this last chapter, but I've got a parabola. What do you know about it if I'm asking you for the equation? We're working backwards now to make sure we get a little variety of stuff. I know it's going down or up, so which equation? Y minus k, a, x minus h. So to fill that in, you need a vertex, which I have. So I can go x minus the 2, y plus the 1, but now I need a. Now, if you're lucky, and you can see the lattice rectum in there, like right here, right there, up to 1, 2, 3, 4, 1, 2, 3, 4. I have confirmation that that's the lattice rectum because the C value is 1/4 of the length. But I can't always see that. Like right here, I don't know. 2, 1, 2, 3 and a half, no, 3, 1, 2, 3, 4 and a quarter. I don't know what it is there. If you can see it, great. Use that lattice rectum that's 8 to find your A value that's 1/8. Or look at this. Down 3 over 1 over 1. What does that look like? Now, if you don't see that exactly at down 3 over 1, like look, at down 2 it wasn't over 1. At down 4 it was past 1. But if you're lucky enough to see that, great. But if you're not lucky enough to see it, which you probably won't be on a test, just pick any point that you feel confident in and plug it in like we've been doing. I'm pretty confident that that's going through 3, negative 4. And if it is 3, negative 4, simplify, A is negative 3, which it was, right? Plug your negative 3 back in, you're good to go. Same thing here. Plug in the vertex, pick a point you're confident in. Of all these points, are you confident in that value? No. That one, no. That one, maybe, but I think it's more like right there. This one I feel pretty good about. Now, actually, I feel pretty good about that one too, and maybe about this one. And ironically, if you pick those 3 points, you actually get different A values. So actually, it's not going through all three. Because if it was, then I'd get the same value on all of them. So in a case like that, which I don't do this on a test, but if that happened on a test, I would take any A value that you came up with, either using that, that, or that. And I might even do that one because it's kind of close. But so I'm fair, but on the ones I made up for your test, I make sure that it only goes through 1 point clearly at the crosshairs of the grid, so that you'll be fine. But on this one, what do you got to do? I know the vertex.
X minus.
Good. I got to start with the right form. I got to start with x minus, right? And ay minus. And if the vertex is 3, 2, x minus 3, y minus 2. And I wasn't able to see anything about that little trick for the lattice rectum or the cheat trick. So I'm going to pick a point. What do you think would be a good point that you feel fairly confident in?
Negative 1, negative.
Negative 1 what?
Negative 3.
Negative 3.
Now, negative 1, negative 3 to me is close. But if you really look at these crosshairs, does it look like it crosses right on them? No, keep looking. Negative 3, negative 4, or negative 3, 8. Those are right on the money. So what do? Negative 3 in for the x. Negative, I'm going to use the top, but positive 8 in for the y. And when I solve, I get a times 36 equals negative 6, so a is negative 1/6. And I'm going to come back in here. So hopefully we're in good shape there, but don't, every year, most of the people that miss this make bad choices about the lattice rectum. Like literally, they look up here and they go, oh yeah, this is what? 1, 2, 3, 4, 5, 6, 7, 8. The lattice rectum must be, the A value must be 1/8. But I didn't even bother to check. Even if that was 8, this would have needed to have been 2, and it's not. Are you with me? So double check if you're eyeballing them. And if you get lucky and go, oh, lattice rectum's 8, double check, oh look, C value is 2. That works. And that's a really quick way to get the A value, because the A value would be 1/8 here. But double check that and make sure it's a correct guess on your part if you're trying that. I think it's a safer bet just to get another point that you feel confident in, like one of those or one of those over here. Right? What is the eccentricity of each of these parabolas here? Nice. Now, write this in standard form of I'm sorry, I should have said parabolic form. If you want to change that. So parabolic form, anybody got any ideas of what you want to do if I gave you, let's do number 6.
Divide up.
Now number 6, if it's a parabola, where do your y squared terms end up?
I thought it always equaled that.
On a parabola?
Oh, wait,
No, what do you mean?
no. I was totally.
Oh, no, yeah, oh, no, all of these are 1 on 10.
I thought you said, I was looking down at my paper and then I heard you say that, because I was looking at the question.
Oh, yeah, no. Yeah, back to number 6. I know I'm jumping around. So on number 6, if I'm putting it in the right form, where do the squared terms end up? So I'm going to move the squared terms over there, and I'm literally going to just subtract them over there. If you want to just move them and flip them or whatever, that's fine if your signs end up opposite than mine, but I am literally doing the algebra, subtracting that and adding that and leaving this. Okay? Y'all with me? Next step. Factor that lead value out. Right? I could divide it out, but then it's down here and it's a mess. So I'm just going to factor it out. And if I factor out a negative 3, what does my y term become?
Y squared plus or minus.
Y squared plus 8y.
Y squared minus 8y, because I'm taking a negative out as well, right?
Oh, it was plus.
Right? So I'm taking a negative 3 out the way I'm doing it. Now, if you left this over here, you'd be taking a positive 3 out. It would look a little different, but whatever. So here I am now. Now, how do I complete squared? So half of it squared is 16, but I didn't add 16 to that side. What did I add?
48.
A negative 48. Be really careful about all the signs involved, right? Negative 3 times 16 is negative 48. That's what really was added. and then I end up with negative x minus 2, negative 3, and then when you factor this, y minus 4 squared. Am I finished?
No, you have to flip it, right?
So if I'm not finished, because there's a coefficient of x and there's not supposed to be, how would I get rid of a negative 1?
Multiply everything by negative.
Multiply both sides by a negative? So when I multiply this by, or divide both sides by negative, when I do this, because it's minus there, I have to distribute it in. But here, because it's times there, I can just multiply that together and not disturb the other part. Right? And at that point, could you tell me everything I want to possibly know?
Yes.
What's the vertex?
Negative 2.
Negative 2, 4. What's the length of my lattice rectum?
1/3.
1/3. What's the eccentricity?
1.
1. What's the equation of the axis of symmetry?
Y equals 4. Or
Y equals 4. What's the C value?
112.
112. Okay, stay with me. What's the focus? Now, which way would you be going with the focus?
Down.
Right.
X first means right or left, right? Which way would I be going?
Right.
To the right. So is the focus to the right or the left of the vertex?
Right.
So I would be doing what? Adding the C to the
Vertex.
what part of the vertex? The X part, because I'm moving in the X direction. So literally, for the focus, I am going to add that to the X part, and that becomes my focus. So what's negative 24 twelfths plus 1?
Negative 22.
Negative 23 twelfths, because I added it. Are you with me?
So if it was like y minus k, you'd add it to the y? Or were you,
If it was Y first,
yeah, would you?
then I would add it to the Y coordinate
Okay.
and not mess with the X. Because I'm going up, right? But since I'm going right, I'm going to add it to the X coordinate. If I was going left, what do I do?
Subtract.
Subtract it from the X coordinate. Y'all seeing that?
Sir.
All right, now, what's the directrix? If I add it to get to the focus, I'm going to subtract it to go to the directrix. So I'm going to be subtracting a 1/12, which gives me
Negative 25.
negative 25 twelfths. But wait, it's not a point. It's which line?
X.
X equals. Because I changed the X coordinate. That was the X movement we were talking about. And I didn't even have to sketch it. You can think through that. All right? Good day. Okay, now tomorrow will not be as bad. Tomorrow and the next day we get a lot of rules thrown at you. Oh, also, when you guys take the PSAT, I think I already mentioned this, they did approve late arrival. So I'm not going to be teaching anything that day. I won't see you guys at all. So next Tuesday, we have scheduled in here.
Are they making us?
Yes, they said they're making us say it. No teacher should be.
What we're going to be doing is just doing another review. So we're going to be starting review number 2, and I think I might try to make the conic sections game. We haven't played a game in here. We talked about this, I think, maybe. Did we? Okay, I have these math games that are actually kind of fun and competitive, and we're reviewing at the same time. So I think we're going to do the game on Wednesday, and then we'll have just a small review in my 5th period class, but you guys won't even be here. You'll take the PSAT all morning and never be here. So you guys will have that Tuesday and Wednesday to work on your review basically at night, the second review. We'll also have Monday to work on the first review, so you'll still have a lot of review days. And then the thing we do in class, the game, you'll have a chance to do like 18 or 20 problems in fast, real time. Like, we're going to put you in teams and you'll compete against each other and whatever. We'll talk about that. And I've got these stupid rules to make it a little interesting and to trick you up if you're not paying attention. But that's part of the fun for me.
Is there an online textbook for?
No, because this textbook's so antiquated, they don't have anything. Only us old guys use this book. It's the classic.
There's no pressure or calories.
was made in the olden days, but it's still,
Yeah,
I
it's
think,
just
better
like-
than all the new
it's like,
stuff.
what do you
Yeah.
do?
For smart kids that don't
Carbon
need
bonds,
extra resources,
oxygen.
yeah.
So like, you put like CO2.
The symbol above it.
Yeah.
Yeah.